Swayam Prabha. Digital India. Educated India.
Welcome back. So, we were discussing the Bitcoin consensus problem, and we ended up with discussing the impossibility result FLP, and we said that that is a worst case scenario, and also there are random, that is for deterministic case, and there are randomized algorithms for Byzantine fault tolerance. But in case of Bitcoin, the consensus works slightly differently than all existing Byzantine fault tolerant algorithms, and actually it works quite well in practice, and the theory is not exactly in line with the practice, and but theory is important because you might think that it is working all the time. So, I am fine, but theory gives you the impossibility results or the lower bounds, which can tell you whether you have not thought about some corner case when your system will not work or not proceed. You may not be able to decide on the next block and things like that. So, but we will see now how this thing works in Bitcoin, and then you will see how we actually circumvent the problem. So, first of all, as we said before, that many times if you change the model of the problem. So, in case of a distributed database consensus, for example, in which context the FLP was thought about, the model does not have a certain elements. For example, it assumes that all the nodes are either going to do the same thing deterministically, and some of them will behave differently, but it does not provide in the model a way to make this malicious nodes to behave correctly by adding incentives. So, in Bitcoin we add the incentive or rewards for behaving correctly, and if you have that, then your model changes, and when your model changes, the existing results may also change because your assumptions have changed. So, in the original Byzantine fault tolerant problem, there was no incentive. So, we were not saying that if you behave maliciously, then you will not get some reward, but if you do not behave maliciously, we will give you rewards. So, if you introduce that, it is a different problem actually. Also, instead of talking about deterministic algorithm, you actually embrace randomness in case of Bitcoin consensus, and we will see how that works. But first of all, in the other consensus, the traditional consensus, we assume that this thing will go in the protocol will go in a round, and then it will eventually terminate, and at that point consensus will be achieved. And then again another proposal will be made, and another round of consensus protocol will start, and then when it terminates, we will have consensus. Here we actually relax that, and we say that there is no deadline for consensus. We do not say that at this point the consensus process ended, and at this point all the nodes should have added the same block as the latest block to their copy of the blockchain. We actually say that eventually the when you look at in the long run, all the blockchains replicas should be same, but we are not saying that at every round of consensus at the end everybody will have the same replica. So, this is called eventual consistency, and this is another relaxation from the original problem, because we are not saying that it has to be round by round consensus. So, in fact, in Bitcoin the consensus happens over a long time scale, and in this case about an hour, but even then after an hour the probability of the different replicas are different becomes extremely low, but it is not deterministic. And then if you wait for 10 hours, then the probability becomes close to almost negligible. And when we say this, this is how we say this, right. So, let us say we have this blockchain up to this. And another replica also have this, they have the copy of the blockchain, and until then they have this, and until then let us assume that they are identical. Now, another block has been proposed, actually multiple blocks have been proposed, and this guy adds one block and this guy adds a different block. So, 1 block 2, and at this point I do not have the consensus exactly worked out, because they decided on 2 different blocks. But we will see over time one of these, let us say this guy after 1 hour will have, let us say 6 more blocks on top of it, and this guy will have only people, some people built the next block on top of this, but other people said okay, this does not look right. So, I will build on top of this, and then this chain keeps growing. Then what we are saying is that at the end this will become consistent. So, this will become what we call an orphan part of the chain, and the chain will proceed here like this, whereas this copy has always been in the right path. Now, it depending on what 1 and 2 are, it could be that this guy will grow up and this guy will eventually converge to this way. So, at this point we do not know, but over time, over 1 hour, when 6 more blocks have been put on top of this one, by then you if it still survives, the 1 survives and 2 does not have 6 blocks built on top of this, and then there is alternative this thing, then they will have 1 has become permanent, and eventually this guy will have this chain replicated here. So, that is the idea of eventual consistency. The other issue is that here we are doing consensus without an identity, right. We do not know who the people are. So, we do not know, we only know their hash of their public key as their account address, and that is all we know about them, and it may be that multiple people, multiple accounts belong to the same person. So, if you are thinking about consensus, if I have if I create 10,000 accounts, but I am the owner of all 10,000 accounts, I may actually think that I have more power to overwhelm the consensus, right. But especially if I am a malicious node and I want to overwhelm the consensus, then I can create that many nodes. So, that when you create multiple alias for yourself and nobody knows that it is your alias, because there is no way to know, and then you get some advantage, then it is called a Sybil attack. So, your protocol should also be robust or resilient to Sybil attack also, right, because otherwise somebody who has more malicious intent will create more IDs, and then he will have more, let us say, voting power, for example. So, therefore, we have to actually make sure that the protocol is resilient to Sybil attack. Now, some other protocols require node IDs, and maybe also they connect that to real world identity. For example, we will see when we look at permission blockchain. In permission blockchain, every node is actually permissioned, and how are they permissioned? Because there is some way of somebody who actually permitted them. So, there is a centralization there, that who permits them, but after the permission process is done, the rest of the stuff becomes decentralized, but in that case we know the identity of each node, the real world identity or some other identity. In this case, in Bitcoin and Ethereum is called permissionless, and we do not know the real identity, and somebody may have multiple identities. In fact, we saw yesterday that the change address, for example, requires that you create your own multiple identities. So, under these circumstances, we have to make some assumptions. So, we assume that we already talked about this, that we have to always assume how many of them are malicious. We cannot say 100% could be malicious, because then the protocol won't work. So, we assume that less than 50% are malicious. So, that is the assumption under which the Bitcoin protocol works. If anybody gets 51% malicious, then and these malicious nodes actually collude with each other, then the protocol won't work. So, as I said that in a P2P system, permission free, permissionless, so we cannot really determine who, and we are making the P2P system in such a way that there is a low barrier to entry. So, anybody can create a public private key pair and enter the system. In that case, Sybil attack may happen. On the other hand, the goal of Bitcoin creation was also not only the decentralization, but also give anonymity. Now, in the very beginning, that this anonymity is not real anonymity, it is actually pseudo anonymity, because people are using various data mining techniques, because all the data of a blockchain, Bitcoin blockchain, are publicly available. So, you can actually look at the correlation between different addresses, how they transact with each other and so on, and they can actually determine that this addresses seem to be from the same entity and things like that. So, it is in a sense that it is pseudo anonymous, but as I said that it is almost impossible to establish the real identity, even if you do all this to know which accounts are together and which accounts are not together, but you cannot really still know who the real person behind that identity is. So, but that is a goal of the Bitcoin. Now, we saw that this goal also has some downsides, which is use of Bitcoin addresses as ransomware addresses, use of Bitcoin in the drug trade and other dark web activities. So, that is a different issue here, but anonymity is the reason why identity is not there, which makes the consensus even more challenging. So, the way the consensus works mimics the following process. Suppose there is a raffle, like you go to a concert and then at the end of the concert there is a raffle, and they will give away a couple of prizes by picking your name from some kind of a hat or some box. Now, they do not know your names, they do not know your identity. So, what they do is that they look to take at the stub of the ticket that you bought. So, it has the same ticket number, and then they put the ticket number in the box, the stubs of the ticket in a box, and pick one randomly, and then say whoever holds this wins, right. So, in there your real identity is not required, you are given randomly some number, random ID, and then I am picking one of them. So, suppose you want to decide that the way I will do the consensus is that everybody proposes their blocks, and then I will give everybody a random ID, and then I will pick one of the random ID, and then say that your block will be the next block, right. So, this is what we want to do, but again we do not have a central authority to do this, right. If there was a central authority, then the central authority can arbitrarily decide whose block will be taken. Central authority could have done a raffle kind of thing to pick them, but central authority is not there. So, we have to actually do it in a decentralized fashion. We want to do this, but we want to do this in a decentralized fashion. The key idea is that in each round a random node is to be picked, and this node will be allowed to give the next block to the chain, and the other nodes will then implicitly accept or reject this block by either extending it. So, when you put a new block to the existing chain, the others may decide that they will extend your block, or they might say I do not think that this block should be there. So, I will go to the previous block and extend from that, and by extend I mean that when I create a new block I put the hash of one of the previous blocks, right. So, I can put the hash of this guy, or I can put the hash of this guy, and then conceptually if I do the hash of this guy here, then I am connected to this, and basically I am extending this part of the chain from here, and if I do this, then I am extending the chain from here. So, that is how I say all the other nodes will say that I accept you as the latest block, right. So, every block decides, every new block that is created will either extend the latest new block, or it will extend a previous block, and accordingly the chain will grow, right. So, this is how the system grows. So, a simplified form of how this works is that all new transactions are broadcast to all the nodes through the peer to peer network. Each node collects new transactions and decides to create a block, and as we discussed that every node may have a collect a different set of transactions into a block, and the blocks are fixed size, and in each round a random node gets to broadcast its block. Now, here we are not saying the whole story, because which random node gets to broadcast its block is something that we will leave it for later. All the other nodes accept the block only if all its transactions are valid. Now, if you have sent a block in which there are invalid transactions, then no node will accept it, except for maybe malicious nodes, which is that money that you are spending has not been spent before, that is you are not doing double spending, and they have to check whether the signature is valid. Then they and this is they will for all transactions in the block, and they say that okay, this block is valid. Now, the nodes then will express their acceptance of the block by including its hash in the next block they create. So, that is the overall scheme of things. Now, this step is what we have to discuss more, because how is this random node get selected, because we have no central authority. So, we have a decentralized system. So, before that, let us see what a malicious node can do. So, let us say I have the blockchain until this, and then I make a transaction which makes into the next block. So, I am giving some money to B, and this is CA is the coin that I have right now, and I sign it. So, it is a valid transaction. Now, what you can do is that you can try a double spend, right. So, you say give this money to my other address. So, A might decide that, so B is a let us say a merchant, and you say to B that send me this package I want to buy, and I am going to pay you in Bitcoin, and the way you know that I have paid you in Bitcoin, you listen to the broadcast, and very soon you will see the transaction where I am saying that I am paying you, and then also if you wait a little more, you will see that in the next block, right. If the merchant believes after seeing the next block that he has been paid and ships the merchandise, at this point what A can do is that once he gets acknowledgement that the merchandise has been shipped, he can actually then put another transaction and then get which pays the same money to himself in another alias, and then make sure that all his friends and others are build the other blocks from the block that contains this second transaction. So, then this block becomes an orphan block if somehow this block becomes extended, and that is a double spending attack. So, an attacker in this case A might actually, then in the meantime the merchandise has already been shipped. So, the merchant, after a while the merchant goes and checks the blockchain again and sees that this has become orphaned, and the current latest blockchain does not contain that transaction, and therefore, he cannot spend the money he got, because his transaction is not there in the actual blockchain. So, this double spend attack is a big problem. So, an honest node is supposed to extend the longest valid branch. So, if this becomes a valid branch, so see this double spend has can be considered a valid branch, because this branch has become orphan. So, this the honest nodes may start building from here, and therefore, depriving B of its payment. So, the merchant's point of view, this is really a loss, because he is not getting any confirmation. So, what we say is when the block makes when somebody makes the transaction part of the block, and that block becomes part of the blockchain, then we say it is a single confirmation. Then when somebody builds another block on top of this block, then we say we get another confirmation, and then we get another block built on the same chain, then we say the third confirmation. So, if the confirmations keep coming on the original one, then Bob will be okay, because after enough number of confirmations this block will become orphan, and so therefore, this attempt to double spend will be getting no confirmation. But in case there is the confirmations keep building. So, normally in Bitcoin until 6 confirmations you do not ship your merchandise. So, that is and we will see later that it takes about 10 minutes for one new block to be mined. So, 6 confirmations will take 60 minutes. So, that is why we say that you have to wait until 1 hour, see that the transaction that you are interested in the block which has 6 confirmations, then you are more or less sure that people cannot really create a side chain which will grow longer, because then another 1 hour has to pass before this can be done, but honest nodes will not build, because this is a smaller chain. So, they will start building on top of this, and therefore, this chain will keep growing. So, this is all probabilistic, because you are assuming the honest nodes listen to they actually abide by the protocols. You are also assuming that nobody acquires later 51% power or 51% nodes do not become malicious and subvert the chain by changing from here itself, like they can start building here. All kinds of stuff can happen, but the probability is very, very low. So, eventually even after 6 confirmation there is a very, very trivial probability of being subverted, but we live with that and normally it works. So, double spend probability decreases exponentially with the number of confirmations, and this can be proven mathematically, because the process of new block creation usually follows a Poisson distribution, and therefore, inter block arrival time is an exponential distribution, and so most common heuristic is to wait for 6 confirmation. So, which is closely an hour. So, to recap, the protection against invalid transaction is completely cryptographic, enforced by the consensus. Protection against double spending is purely by consensus. So, when you check for a transaction's validity, the consensus does not come into play. If a transaction is invalid, every node will see that by checking the signature and whether the money belongs to you and things like that, and that can be done all with cryptographic techniques. Protection against double spending is actually has to be done through consensus, and it is probabilistic, and you are never 100% sure that your transaction is in the consensus branch. The guarantee is probabilistic, but with overwhelming probability. So, that is the what we have seen so far, and now we talk about the incentives. So, incentives are actually important part of the problem of consensus in blockchain. So, we talked about this earlier, that unlike the classic system of consensus distributed computing, Byzantine fault tolerant computing, there we do not try to change the malicious nodes behavior towards behaving correctly, but in here we actually do that by giving incentives. So, let us look at the incentive mechanism that was put in place for this. So, can we give nodes incentives for behaving honestly, or can we penalize the nodes that behave dishonestly? Now, if there was a centralized system, somebody would be actually determining, oh, this behavior is not acceptable, this behavior is acceptable, so we should penalize, but there is no central agent or central authority to do that, and therefore, we cannot do this directly. So, we have to have some mechanism for incentive, and those who are not behaving correctly will not get the incentive. So, that is how it works. So, therefore, what we would going to do is that we are going to show you 2 incentives, right. One is that when your block gets added, you can add a special coin creation transaction in the block and put the recipient address yourself, right. So, whoever creates a block, he assumes that his block will be accepted. So, in that block he adds an extra transaction which we call a coin creation transaction, which creates new coins, and then he puts the recipient address as one of his addresses. He has many aliases, he will put one of his addresses. Now, how much he can create for the coin creation transaction is fixed. Right now, it is a 12.5 bitcoins, but it halves every 210,000 blocks, and so far with the 10-minute interval between blocks, it is roughly about I think 4 years. So, therefore, right now if I create a block, I will put a transaction saying that create 12.5 new bitcoins and give it to my address. Now, if my block gets accepted, then that transaction becomes part of the blockchain, and then after 6 more blocks are built on that block, I get to use that 12.5 blockchain. If my block does not get added to the blockchain, or if it gets added, but nobody builds on top of it and I do not have 6 confirmations, then I cannot use that those blockchains that I created, even though I put it in the block. So, the block creator gets to collect the reward only if the block ends up on long term consensus branch, the branch that has many others built on top of it. So, at least 6 blocks has to be built on top of that in order for this to be able to use that 12.5 bitcoin. Earlier it used to be 25 bitcoin, and in the beginning it was 50 bitcoin, and later on it will be 6.75 bitcoin and so on. So, and there is a finite supply of bitcoins. So, only way to create bitcoin is by this process, right. Your block has to be accepted, you will get reward, and this way every 10 minutes somebody or the other will get some rewards, and then more coins will be created. Now, in the beginning, as I said, it used to be 50 per transaction. So, the slope was higher of the total number of bitcoin in the system. Then it became 25. So, the slope was lower, and then now it is 12.5, the slope was even lower, but you see the number of the time required to reach that 210,000 blocks is shrinking, right. So, this is 210,000 blocks were created in this much time. Here it is much smaller, and this took 210,000 blocks require a lot longer, I think, right. So, so therefore, these things and then it will become 3.725 or something, and so on. So, eventually it will taper out 2040. By then the total number of bitcoins will become 21 million, and beyond that no more bitcoins will be created unless the rules change. So, this provides the bitcoin ecosystem some scarcity, right, because if you have infinite supply of bitcoins, then the prices will not be high, right, the exchange rates will not be high. So, therefore, in order to build in this scarcity, they have decided in the beginning that there will be only 21 million bitcoins created. So, we will talk about the other incentive in the next session. So, at this point we have learned how to do one type of incentive for nodes who play by the protocol's rules.